Welcome to the fourth section of the conics, which is parabolas. A parabola is a set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point called the focus, not on the line. So this is the third time that we have talked about the focus. There's only one in a parabola, but there was two in a hyperbola and two in an ellipse. The midpoint between the focus and the directrix is the vertex. That word directrix might be a new term for some of you. We'll talk about that. The line passing through the focus and vertex is the axis of symmetry. That is definitely something you're familiar with. And then the axis of symmetry and the directrix are perpendicular to each other. Okay, so let's go ahead and take a look at a visual here so you can see where all this stuff is located. First off, a vertical parabola will always be y equals, and this is the same thing that you've learned before about parabolas. This is in what we call vertex form. And the reason it's vertex form, because you've gotten quadratics before like this, you've done standard form, things like that. This is vertex form because it gives you exactly that. It gives you the vertex, which is h, and k. So this is the fourth time that hk has been kind of that center point. Now a parabola doesn't have a center point, but that's the max or min of the parabola. So if it's vertical, it's y equals. If it's horizontal, it's x equals. So vertical, you can think y axis, horizontal x axis to be horizontal. And then take a look at the picture here. We've got a couple different things. We have the axis of symmetry, cuts the parabola in half. You have your vertex, which is the max and min of the parabola right there. You have the focus, which is inside the parabola, which is true about the ellipse and the hyperbola. The hyperbola, the focus was farther out, but it was still inside that hyperbola as it opened. And then you have your directrix. But take a look at the distance from the vertex to the focus is c. Same c value we talked about with the ellipse and the hyperbola. And then the distance from the vertex to that line, which is called the directrix, is also c. So the vertex is in the middle of those two. Also, when you graph this, we're going to do twice c from the focus to figure out what the width of the parabola will be. Just like the other conics, to find c there was some relationship. Well, on this one, the relationship is 1 divided by 4a. So 1 divided by 4a will give us the c value of the parabola that we're dealing with. The a value is, when we did transformations, remember that was your stretch and compression. That was that multiplier that we talked about. A couple things that you might remember. The graph will open up if a is greater than 0. It'll open down if a is less than 0. In terms of horizontal, same idea. If it's a is greater than 0, it'll open to the right. If a is less than 0, it'll open to the left. And everything's the same over here as well. This distance is c, this distance is c, and then this distance is 2c. So let's go ahead and look at our three types of problems that we've done throughout all these conics. The first one is we're going to go ahead and look at a graph, and let's identify the important aspects of this. The first thing is it horizontal or vertical? Well, since it's x equals, think x-axis, and this will be horizontal. We know what the vertex is. Now pay attention here because there's only one squared term now, whereas the other three there was two squared terms. This is your k value because it's y that is being squared, and this is your h value. So your vertex in this one will be -3 comma +2. This one is not being squared. The h isn't being squared. It's not a binomial squared like the other one. So pay attention to those details there. Okay. So we have the vertex. So we'll go ahead and plot that. -3, 2. We know the graph is horizontal. We also know which way it's opening. Let's write that it's going to open to the right because a is greater than 0. We need to figure out that c value. So C is equal to 1 over 4 times A, and A is 1/4, so 1 over 4 times 1/4 is 1 over 1, which is 1. So that distance is 1. So the focus, since it opens to the right, is 1 unit over. And since it's horizontal, we're going to add to our x value. So the focus is -2, 2. We went 1 unit to the right because it opens to the right. The axis of symmetry, let's do a dotted line. Through those two. And then our directrix will be 1 unit to the left of the vertex. So our axis of symmetry will be y equals, because it's going through the y-axis at 2, and our directrix will be x equals, it's perpendicular, and it's going through the x-axis at -4. So really we have all the information. Now it's just a matter of graphing, but we need to move 2c, which in this case is 2 times 1, which is equal to 2. That's the distance from the focus to the outside of the parabola. You don't need to label those points, you don't need to tell me what they are, just graph them. And then now when you graph your parabola, make sure you hit the vertex and then those 2 outside points. And that's how you graph a parabola. And that's a horizontal one. Vertical works the same way, except you're going to be opening up and down, things like that. Okay, let's go ahead and look at an equation. Now, before we just jump into this equation, look back at the general forms of the equation. These are x equals and y equals. Well, how do we know how to start this problem? Well, first off, we're only completing the square once. On this one, we have an x and a y. So we want to solve for the variable that's not being squared. So let's look for this. So we have this one being squared, and then the y not being squared. So that's the one we want to solve for. Okay, so let's get it to the other side. We're going to add 12y to the other side. That gives us 12y equals, and now I'm going to set this up as x squared minus 2x plus blank, because we're going to complete the square. But then we have this plus 25. Alright, we can move it to the other side with the 12y if we wanted to, or we can just kind of push it out of the way. Okay, I'm just going to, so to speak, push it out of the way. And then let's go ahead and complete the square. We've got 12y equals half of -2 is -1. -1 squared is 1. So we've added 1. So usually when we add 1 to one side, we have to add 1 to the other. But if I add 1 to this side, what am I going to have to do anyways? I'm going to have to turn right back around and subtract it. So if you want to kind of save yourself a step here, instead of doing it that way, which is perfectly fine, you can say, well, if I just added 1 here, then I'm going to subtract 1 here. And so what you've done is you've added 1 here, but then you turn around and subtracted it on the same side, so it keeps it balanced. Completely up to you on how you want to do that. Either way is fine. So it'd be plus 24. And then now your last step is to divide by the 12 to get y by itself. So y equals, there's a 1 right there, so I want to see the whole, that a value, 1/12, x minus 1 squared plus 2. And there's your equation. So that's it in terms of writing the equation. If you want to practice this one real quick and see if you can go ahead and graph it, not a bad idea. I think I'm going to go ahead and do it myself, so if you want to pause and try it yourself, that'd be a good idea. So here we go. Since it's y equals, alright, we know it is vertical. We also know it's going to open up. We know the vertex is at 1, 2. The c value is 1 over 4 times 1/12. So 4 times 1/12 would be 1/3. and then 1 divided by 1/3 is 3. So the c value is 3, and then for later we're going to know that 2c is 6. So the focus is 3 units above the vertex. So we're adding that to our y value, so that should be at 1, 5. The directrix is 3 units below the vertex, and the axis of symmetry goes through those 2 points. So let's see, let's do the axis of symmetry. That goes through the x-axis at 1, and then the directrix is perpendicular at y equals -1. So there's your information. We just need to go 6 units from the focus. 1, 2, 3, 4, 5, 6. And same thing here, 6 units. So it's going to be a pretty wide parabola. And there you go. So there's another example of the graph. Let's go ahead and work backwards now. Write the equation of the parabola with the focus 2, 1, and the directrix is x equals -2. What are the things that we need to know for a parabola? We need to know if it's vertical or horizontal. We need to know the vertex. And we need to know the a value. Those are really the 3 things that we need. So let's kind of figure out what we have here. The focus is at 2, 1. The directrix is at x equals -2. That's over here, which means the axis of symmetry has to be at y equals 1. The vertex is in between the directrix and the focus, so halfway in between there would be right here. So our vertex is at 0, 1, and we also know it is horizontal. So that's good so far. We only need to know that the a value is. Well, we know c has a distance of 2. So if c is equal to 1 over 4a, what is a equal to? Well, we could just plug in the c value and solve. Let's just go ahead and do that. Plug in 2 for c, so that would be 2 equals 1 over 4a. And then that would be 8a equals 1, so a is equal to 1/8. So the other thing maybe that I kind of forgot was we need to know the direction it opens, because that's going to depend on whether a is positive or negative. So on this one, it opens to the right. So that means a will be greater than 0. So we need this, 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 and this. And now we can write the equation. It is horizontal, so it will be x equals the a value of 1/8 times y minus, now we need the y value, which is 1 squared plus the x coordinate of the vertex, which would be 0, so you don't necessarily need that. And there you go. There's your equation. Alright, let's go ahead. I actually have 2 of these, so if you want to go ahead and try this one on your own and see if you can do it, go ahead. I'm going to go ahead and start though. Write the equation of the parabola with the vertex -2, -3. So that would be right here. There's the vertex. Axis of symmetry is at x equals -2. And through the point -1, -1. You've had these questions before. I've had a couple people ask me about them, so this would be a good time to talk about it. So what do we have so far? We know the vertex, so that's good. We know the axis of symmetry. Okay, so that actually tells us that it is vertical, so that's good there. We don't really know whether it opens. I guess if it goes through the point -1, -1, let me plot that right here. So I guess we do know it opens up. So that means a is greater than 0. But we don't know what a is. So how are we going to find that out? Well, let's write the equation. It's going to be y equals a times x minus h squared plus k. Let's see what we have here. We have h and k, and we have x and y because it says it went through a point. So we actually have 4 out of the 5 things. We don't have the a, so that's what we're going to solve for. So let's go ahead and plug everything in. Negative 1 equals a, we don't know what that is. X is also negative 1 minus h, which is negative 2, squared plus k, which is negative 3. Let's simplify. Negative 1 equals a. That would be plus 2, so 1 squared is 1 minus 3. So that's 1a minus 3. Add the 3 to the other side. That's 2 equals 1a, or a equals 2. So now we have everything we need. Vertex, vertical opens up, and a is 2. So the equation would be y equals 2 times x minus negative 2, so it's plus 2 squared, and then plus k in this case would be minus 3. So there we go. There's another example of working backwards with parabolas. Alright, that is it. I hope that helps understand the whole thing of parabolas.